will see various types of experimental design. Experiment is a method and there are variety of designs available to any experimenter. If we know them as per our needs, we can employ various designs. While planning and selecting a design, we must also know which is the best possible in the circumstances. There are 4 types of experimental designs. Pre-experimental design, true experimental design, factorial design and quasi-experimental design. Can you guess from these titles which is the best one? It's giving away, the meaning. True experiment must be the best. Pre-experiments are before you achieve the experimental step, you are doing something, cannot be called as experiment, you are doing something which is pre-experiment. But we will see that we should not be taking stock immediately before we go in. But I am just asking from the titles itself if you can see. And time series design is also called, comes under quasi-experimental design. Let's see the first one, pre-experimental design. What does it say? Single group post-phase design. Now we will see how the terminology is used. You have also seen there, T stands for treatment, isn't it? So you must use the same terminology here throughout the experimental design. Single group post-phase design. What does it mean? There are no 2 groups. Experimental control is not there. There is only one group, that is single group. And post-test, that means we have not given them pre-test. We have taken a group and we have just found a variable. So that is called single group post-test design. Treatment and post-test. Post-test scores are shown by T1 and T2. T1 is pre, T2 is, and treatment T is shown by capital X. Now, how would you rate this? What control? Now you see the threads. Internal validity thread, external validity thread. What we said there? We have to randomly select both the groups. Basically, there are no 2 groups, only one group. So how you can compare? Isn't it? There is nothing to compare. So there is no control on extraneous or situational variables at all. Same group, one teacher is teaching, whatever treatment you are giving to the same group. Now, single group, pre-test, post-test design. Little improvement. Group is only one, but you test them before, then you give them the treatment, and then you test them again, so that how you will find whether your treatment is effective. You see the difference between pre-test and post-test. If there is increase, you will say it is because of your treatment. Can you really say that? It is because of your treatment. In pre-test, average score is 45. Then you give them the treatment and then you give them the post-test, the score is 60. So you say that there is an increase of 15 scores and it is because of the treatment. Am I right in saying that? You have not controlled many variables. Say in between, some other, say Professor Jayant Narikar had come and he addressed it. Or Sunita Williams had come. Maybe they got inspired to learn science. Isn't it? And it's not because of your treatment, it is because of visit of Dr. Sunita Williams. If there was a comparison, so both the groups get Sunita Williams lecture. Suddenly Dr. Sunita Williams came from NASA and she visited your school and she met the students and they inspired them something happened because you had not planned that. So your dependent variable is that rate. The result what you are showing, 15 scores are increased, need not be only because of your treatment. Then the third design. Two groups, static design. What are these? One is experimental group and other is control group. Experimental group always gets a treatment and control group does not get a treatment. But it is only post-test, static. So you are not giving pre-test to both the groups. You select two groups. How you select? I am not said randomly, right? As you like. They are not selected randomly. That's why it is called pre-experimental design. You take any two classes. The one you like, you teach them experimental. One you don't like, put them into control. Anything can happen because you have not randomly selected them. Nowhere it is said that they are randomly selected. And treatment is given and no. Most tests will tell you there is a difference. But there are situations where you cannot always say that I want to randomly select. You can't do that. Whatever you get, because all the time you don't have a control on the subject. So, but in that case, you have to conduct an experiment, you conduct an experiment. That's why it is called pre-experiment. This is not done randomly. In experiment, it is always randomness which is important. Second is true experimental design. See what is written there? Two groups, randomized subjects, post-test only design. This word itself is very important. It makes the experiment true experiment. There are groups and you have no bias. You are putting students into experimental and control group randomly. Random selection. Anybody can be in the experimental group, anybody can be in the control. And that's why you have every control over the subject. But it is only post-test. Second type is two groups, randomized, match subjects. One step ahead. They are randomly put, but as I said earlier, both of them have 60 marks. Now randomly you are putting them. One goes here, another goes here. So they are randomly put into two groups, but they are also matched. So it is much better experimental design. The third is two groups, randomized, pre-test, post-test design. In the first two, there is no pre-test and third is post-test. And randomized Solomon 3 groups design. Randomized Solomon 4 groups. We will see each design now. First one. The word randomized is underlined, is bold. You must understand the importance of randomization of subjects. Generalizability depends totally on randomization. Otherwise, you can't generalize. Many researchers do that. They select the school next to their home. In my colony, I have a school. So it becomes a purposive sample. It is a purposive sample. And in that school also, I am teaching to 8th standard, so I am conducting experiment on 8th standard. That is another blunder which we create. So it is not randomly selected. So two groups, randomized subjects, post-test only design. How it is represented? Experimental group and control group. Treatment is given to experimental group and post-test to both. So there is no test wiseness. You see that internal validity threat? We have not given pre-test. So the threat is less. Second design, two groups, randomized, match subjects, post-test only design. So you have not given them a pre-test. There is no pre-test. So you can't test their scores in mathematics. But can you give them attitude tests and say those who have similar attitude, one can go here, one can go here. So they are ranked. And one seat you put here, one seat. So you have not even seen their name. You don't know them. So you are testing them on attitude and then putting them in two different groups. And both the groups are now rated. One group you give the treatment, whatever method you want to try out, or e-content you want to try out, some strategy you want to try out, whatever. That is the treatment given to one group. And both undergo the fourth stage. Now, if there is a difference, then safely we can say that both of them were matched. Initially, they were matched on attitude. You can match them on 2-3 variables also. You can match them on age. You can match them on sex. So, if you have all girls in one and all boys in other, there may be some traits of girls which are not common with boys. So, maybe that is affecting. So, you can have similar number of girls here and similar number of boys here. That's possible. Age also you can match. Socioeconomic status you can match, because those who are coming from low socioeconomic strata and those who are coming from higher socioeconomic strata, their previous experiences will be different. So you can match. So on various variables you can match them. You can give them the inventories, questionnaire, get their score and then match them, and exactly matching them you can randomize them.